Oh, thanks, Peter, for that introduction, and thanks also to the ARC for hosting this event. Peter asked me to talk a little bit about being a student here prior to VUWAE 15 in 1971, and just reflecting a little bit on the school, on the department then, and on the culture and how Antarctic studies came into being in a way. So I'm a Wellington boy, brought up in Situn, attended Rongotai College. And when I got into the upper sixth, I was interested in science, but I wasn't quite sure where I was heading. And we had a geography teacher who told us about some evening classes being held at the Geological Survey and conducted by quite a well-known geologist, Graham Stevens. And he introduced these classes, which were quite interesting because we never learned anything like that at school. And then we had a next door neighbor in Seaton, and he was very friendly with Dick Willard, who was the head of the Geological Survey. And he was up on Strathmore Heights. So he arranged for me to go and talk to him. And basically that put me on the path to actually studying geology at the university. Now, how do I go here? So this is all interesting. So I can't run it off the map off here. I want to change slides. So which one is the mouse? It's not working. So that doesn't work. I was wondering. Ah, yeah, there we go. Okay. So what did you click? What did you click here?
Oh, something just used the mouse.
Yeah. Okay. So stage one geology, and the prof then was Bob Clark, and we all rolled up in the Easterbrook building on the 5th floor, and we went into stage one geology. The classes were pretty full. The lectures were always held around 5 o'clock, and Bob Clark would roll up on the first day. He sat us in the class, and as John reminded me not so long ago, he said, look to your right, look at the person to your left. Only one of you will be here next year, which was quite intimidating, I must say. And then he said, it's compulsory to buy this book, Principles of Physical Geology. That is the text for the class. That is a book which I measured the other day. Everyone had to buy it. Probably today, OH&S would say, this is not acceptable. The student may get a hernia or something from carrying this thing around. It was 8 centimeters thick. 1,288 pages, and this was the text for physical geology. That was the class text. And the other thing that Prof. Clark said was, you can be sure that in the lectures, in the exam for the first term, you will be compelled to know the geological timetable, time scale. He said, if you don't know that, you can't get the first base. So you do know that's going to be in the exam. Now, why Arthur Holmes? Well, Bob Clark was Arthur Holmes' PhD student. And Arthur Holmes was one of the most famous geologists ever. So Bob Clark had done his PhD at Edinburgh University. He did his PhD on Arthur's Seat. If anyone's ever been there, the castle at Edinburgh sits on Arthur's Seat, which is a carboniferous volcanic structure. And Holmes was known for two things. He was the guy who provided the earliest ages on the age of the Earth. And during his lifetime, he said the age keeps getting older because we're finding out new ways of dating the Earth. And he was also, you may not see it here, he was the Vetlesen Prize winner in 1964. Vetlesen Prize is the Nobel Prize in Earth Sciences. And today it's given out by Columbia University. And he was, it had been established in 1959, and he was the third winner of that prize. So he was a very, very well-established, well-known geoscientist. And he received the prize for two things: for determining the age of the Earth, the earliest uranium-lead, some of the earliest ages, and also for invoking mantle convection currents, which are the drivers of plate tectonics. We didn't know at the time, but that was what he was known for. So Bob Clark was his student, and he came to Victoria in 1954 and was the Professor of Earth Sciences. So there's a certain amount of rigor in the whole course. Stage one was full of large classes, probably two labs for everything because there were too many people. And we got into indexing thousands of crystals, learning lots and lots of minerals and fossils. This was, but only when we got to stage two did we really crystallize more into a unit, into a class. And that was really around the time that we went off and did a camp with Harold Wellman, Kekarengu. That was the Kekarengu field trip and basic mapping. And that was when we all sort of really crystallized into a group, got to know each other better. And of course, Harold Wellman was arguably the most influential geoscientist, New Zealand geoscientist last century. And Harold was a sort of a very interesting guy. He would come down to the tea room and he'd bring in new things. He'd come in one day and said, have you heard about all these magnetic stripes people have been talking about on the ocean floor? Or he'd come in and talk about something he'd just been doing in the South Island, going with his wife on a kayak and carrying a magnetometer and coming up with all these anomalies. He was a real catalyst for discussion and innovation, really. But when you took his class, he would come in and talk about what he'd been thinking about on walking down from up in Kelvin somewhere that morning. So you never quite knew what was going to be in the exam. But at the time in the school, there was a lot of things going on besides stage one. Firstly, Prof Clark, Prof Wellman, and then some of the senior students, they all went to home brewing. So there was this rivalry about bringing in beer and testing their home brews, and refusal was at your expense, of course, if you refused them. The other thing that only as we got on to more senior ages in the school did we find out a little bit more about the Antarctic program. But one of the things we couldn't do initially was to go down to the George on a Friday night, which was the meeting place, because the drinking age then when I started university was 21. And only in 1967 was the actual 6 o'clock closing time, which was we call the 6 o'clock swill in the pubs. Only that was then extended to 10 p.m. But only 2 years later in 69 was the age actually reduced from 21 to 20. So we could go down, if you're already in the third year, you could probably go down to the pub and not have to look over your shoulder all the time. Okay. And of course, it was only in the mid-90s when they actually dropped the age down to 18. So when I went through this place, we couldn't really participate down at the George until we were around 20, legally anyway. There were soccer matches, and these are later ones. So there was actually a bit of interaction between staff and students. So here you can see, this is the Paul Vella, who was a professor of paleontology. There's a very young Peter over here. And you can also see some of the members of our expeditions there. And this is the latest, some of the technical staff. These are some of the people who are on our expedition. So there was a lot of interaction. Other opportunities for students were that there was a very active program in monitoring White Island. So White Island, and Prof Clark played this card. He said, well, if White Island blows up, the Bay of Plenty might endure a tsunami or something. So he justified this program, this interdisciplinary program on White Island. And we could, if we were lucky, we could get onto this program which worked with the New Zealand Air Force and would fly out to White Island. There'd be people there looking at seismometers, geophysicists measuring magnetic surveys. They were looking at fumaroles, they were looking at chemistry and temperatures. So this was a chance for a student to actually interact in other things outside the normal sort of studies. So around that time, there was also, we began to hear things about Antarctic program at the university. And we would hear lectures from people who had been to the Antarctic and would tell us a little bit about this place. And it was a very attractive sort of idea for young people. And one of my classmates, Vince Neal, he was on an expedition in 1967 and he came back talking about it all. So we began to get sort of interested in the Antarctic program. And of course, the Antarctic program was started in 57 by, from the university. There was the International Geophysical Year, and many of you will know this. And two students then, Peter Webb and Barry McKelvey, were third-year students who were quite keen on Antarctica, and Prof. Clark sort of saw something as an opportunity here. And these guys, he put together, he persuaded the university and the Ross Dependency Committee that these two guys could go down. They sort of got on a ship and they were nearly bumped off because they weren't really official. They weren't part of the plan for the IGY or the science of the IGY. And they were nearly bumped off in the last minute because of two carpenters, but two carpenters pulled out. And so they took this opportunity. The funding for this trip came from Bob Clark from the university, put in the university put in, they got £100 for it. And then the university pulled out £50. So they had £50 for this expedition. Prof. Clark supplied them with his battle dress clothes from the Second World War. They had nothing. So he lent them his warm clothes, and they got down to Scott Base, and the leader of the New Zealand scientific side of it was Trevor Hatherton, who later became the head of geophysics, DSIR. And Trevor writes, he said, I drove across from Scott Base to meet the boat, and these two young people got off. He said, he asked in some expletives, who the hell are these guys? And then he sort of said, here these two guys came unheralded, uninvited, and unwanted. And here they were in Antarctica, and they managed to wangle their way partly through the help of the guy who was organizing the US part of their scientific expedition, and they got into the dry valleys of Antarctica. And here you can see this area of the dry valleys, which most of you, some of you will know over here, and they started mapping. And they came back, and obviously they did a good job. And Prof. Clark was very rigorous and said, you've got to get this out, you've got to publish this. And lo and behold, they published stuff very quickly in Nature. And they were off, and they went down the next year. And that was the second, and then the expeditions incorporated other people from within the university. And so they established basically VUWAE 1 and 2, and then it's run off from there. And the first few years, basically, most of the science was based around the dry valleys. And so the sort of subjects you'd hear about would be, why the dolerite sills here, why they're holding back the ice, what's going on here. Lake Vanda here became a very attractive part of their science for a few reasons. Lake Vanda has got about 12 feet of, or say 3 or 4 meters of ice on the top. And some Americans had been drilling in there a few years previously to look for algae in the lake. And they found algae at the bottom of the lake, but they also found that the lake was quite warm at the bottom. And so the geophysicists said, God, we've got to go down there and study heat flow, see where the heat's coming from. And eventually, Harold Willman and Alec Wilson, who was then the professor who was in chemistry, one of the things Bob Clark did was, at a very early stage, he did not just get geologists involved, he got chemists involved, he got physicists involved, and he also got the biological community involved. And lo and behold, the other thing that attracted Harold was that you can see these high level up here. He was thinking of tectonics, of course. He'd been out at Turekari looking at raised beach levels. So he said, what are these raised levels here? What does that signify? The lake is 5 kilometers long, and it has 12 feet of ice. It's a few hundred meters deep. And when they actually went and explored it, they saw that it's a very saline lake. It is 9 times, let's say it's much more salty than the Dead Sea. And the temperature is stratified. So the bottom of the lake is 24, 25 degrees. And as you go up, the temperature comes down, and it's about 2 or 3 under the ice. And they developed this very famous idea of how the lake heats up, but it has nothing to do with heat flow underneath. It's related to the way the ice is bringing in the water. So there were many ideas going on about science, and we were exposed to this sort of science going on. And we were, we would hear about the dry valleys, yes. We'd hear about salt weathering. You can see all this idea that all these landforms that we see in the dry valleys are formed by salt. So we hear all about the salt weathering, salt in the water. So a lot of chemistry going on. Wilson went to the South Pole and came up with all these ideas. They were checking out how much nitrogen is fixed in the atmosphere. Where does our nitrogen come from? How much does the aurora, what role does it play in contributing to the nitrogen in our atmosphere? And they were also looking at micrometeorites. So there were many things going on in science which were attractive. But most of it was in the dry valleys. And there was a feeling after about 10 years of mainly people working in the dry valleys. I think Bob Clark said, well, you know, the dry valleys, we can dot the I's, we can collect more stamps. Maybe we have to do some other things as well. And so he spoke to Peter Webb and Barry McKelvey in 1968, and they devised a new program which would take us to areas which were to the west of the dry valley areas. And they thought they could do all that by helicopter. But it transpired that when they started talking to the Americans, what happened was they said, you cannot load everything you need for a sledging expedition with helicopters. You need to do this with planes. And so they postponed the whole expedition for a year. Then Peter McKelvey, who was then based at Armidale in New South Wales, sedimentologist. Peter Webb had gone off after 58. He'd gone to Utrecht in Holland. He was a micropaleontologist, did his PhD there, came back and worked in the Geological Survey as a micropaleontologist. And so this expedition was organized for this area to the west, and it was going to concentrate on fish fossils which had been found in the earliest expeditions. You should realize that at this stage, Peter came to the university a couple of years later, but Peter had found an amphibian jaw basically in an area. And the whole idea then was, what is the connection between Antarctica, Gondwanaland, the idea of continental drift, where that was all very new. Plate tectonics was just starting to surface a little bit in this lexicon of the geoscientists. So I was lucky. I'd finished honors, and my honors was actually, my project was based on, I was asking Peter, which building were they building to the south of the Easterfield around the time I was doing honors? Of course, he wasn't here then, but it's either the Rankin-Brown. So we had these huge excavation sites here, and Prof. Clark said, why don't you go and do your honors project on this excavation, which I did. And I could see that the Ohio Valley fault came through here at some stage anyway. But and then they advertised for people to go on this expedition. So after speaking to my classmates, Vince Neal, I was then embarking on a PhD, which had nothing to do with Antarctica, and it never did afterwards. And there were about 15 people who applied, and I was selected, and I don't really know why I was selected. The only reason I can think of was, okay, well, you know, I've done honors. And the thing was that one of the things that was attracting students, what was the big issue for students around the mid-60s to early 70s, it was apartheid in South Africa. Should the All Blacks be touring or not? Should they be coming here? And then there was the Vietnam War. And because of the Vietnam War, New Zealand sent a contingent through ANZUS or some agreement to Vietnam. So all the permanent soldiers, a lot of them went to Vietnam, and they had to fill the gap in Australia. So in Australia and New Zealand. So what did they do? They set up a program where they balloted people's dates into who was going to be called up to fill in this gap. And it's the only time in my life that I've won a raffle or any ballot. And my birth date came up. So I went in with a university crowd into the army, and I became a medic. And I think, having been a medic, basically in the end of the day, what we had to do after all the courses and everything, I used to go in with all the summer crowd, it was basically, if there was a big earthquake in Wellington, we would be capable of setting up a 600-bed hospital in the Basin Reserve. That was what I did. But I think it was because I could call myself a medic that they took me down to Antarctica as a medic. And so we went down in 68. We went down with Peter Webb, Barry McKelvey, and then we had myself and Mike Gordon, who was also, he was an MSc student, a petrologist. And then at that stage, the Italians were becoming interested in Antarctica. So we took down two Italian people, Carlo Mori, who was an alpinist and a adventure reporter for the big Milan newspaper, Italian newspaper, La Corriere del Sera. And he'd also been a member of Thor Heyerdahl's Ra expedition. So he was a real adventurer. And then there was Alessio here, who was an alpinist, and also the Italian bobsled champion. So this was our group. This was our group of guys, and they would guide us over crevasses and over areas. So let me just speed up. I'm going on a bit. So it was a very different type of expedition. So we were put in by Hercules. Hercules didn't know, no landing strips, landed, put you in the field for a month or so, and everywhere you get around, expedition, beautiful shots. Obviously, no idea of scale. There's our camp down here on the Skeleton Neve. And basically, this was Christmas Day. You could see how the fuel drums had been blasted by the ice here on the side here. And the red and green with the white set the tone for with the Italian flag. And of course, the Italians had bought a lot of Asti Spumante, white wine there, and they were using that liberally. Okay, so that was that expedition. And what was the highlight of it quickly? The highlight was that we found some of the best preserved fish fossils. This is a lower jaw of a Crossopterygian, which was an air-breathing fish. You can see here two types of dentition, conical, these tusks and these little conical teeth here. And they had these armored plates. We walked over pavements of these things. And basically, these were the fish which were just about, these were our ancestors. They climbed out of the water and they gave birth to tetrapods. So these were our ancestors at the highest level in the aquatic environment before they climbed out and became tetrapods. We also found tillites. These Plumocarboniferous tillites hadn't been found in this area before. And then we had these magnificent sills, this dolerite sills. And you can see here, just to give you an idea of scale, that's about 240 meters, that scale. And you can see this mega sill, and then there's layering here, which were later picked up in VUWAE 15. So magnificent scenery and magnificent geology. Well, we couldn't do everything. Anyway, this attracted a lot of attention in the press. So we've got good press here for the university and for us. And our first paper, my first paper as a student, goes into Nature. And you wouldn't get this sort of stuff in Nature today, but this was the time when they were interested in Antarctic. Was sort of esoteric. It was new. It was very strange. And basically, we'd found these tillites, and you could start talking about things with continents and drift and how things were connected. All right. So that gave, and just to show you, that gave birth to things which were in VUWAE 15. So we discovered this thing. We couldn't do it. VUWAE 15 picked up. And so we went from reconnaissance into more details. And so this is this layered Mount Warren area that we talked about. That's an outcome from that thing. So it's just showing you how these things evolve. And so let's just conclude quickly. Prof. Clark. There was no linkage to grants. We didn't have big grants. We didn't have grants from Marsden or the Endeavour. So we weren't linked to grants. So there was a lot of free thinking going on. As a PhD student, I came in and nobody said to me, go and work on this. I've got money. This is what you have to do. The idea was pick a subject of interest, read the literature, find the holes. That's your PhD. And that was how it worked. And so it was very much a sink or swim attitude. And so Prof. Clark had a strong encouragement of research and publication. Di, who's here, was a fellow student of mine, Di Seward, and she was working in the Wanganui Basin, the most complete Neogene marine section in the world, Lake Neogene. I was working in the North Island volcanics, and there was a problem with where carbon-14 stopped. How do we date things older than carbon-14? There was a big interest in the tempo of rhyolitic volcanism. And so we developed these methods, but he gave us a license to fail. He said, it's okay to take risks. And if you fail, you've learned something and move on. And so that was the attitude. And that was very much fostered by Bob Clark. And his persistent character sustained a long endeavor of Antarctic exploration and research through the VUWAEs. And again, he was behind it. He was very persistent. He didn't sit down and write publications, but he was always there guiding people through the university system. He was a great politician within the university system. He knew how to intimidate committees and people in a very nice way. And as David Reid recollected, when he met Bob Clark down in 71 at the base, Dave Reid was saying, well, how do I get picked on this VUWAE 15 expedition? He said, well, he was looking forward to geology as a scientific discipline emerging from stamp collecting to embracing numeracy, qualification, computation, and instrumentation. And so that's my, and my last thing is from Peter Webb, when he wrote the report, the introductory comments in the report to our 68-69 expedition, the first thing he said was, you've got to keep this thing going. Peter didn't go to Antarctica again with VUWAE. He went off, he became the chairman at Northern Illinois University and then ended up at Ohio State, where he was the prof for many years. Barry McKelvey continued at Armidale. And basically what he was saying was that it teaches a participating student a sense of responsibility, resourcefulness, leadership, and patience. And he said contributes to the emergence of a more mature graduate. For me personally, my PhD had nothing to do with Antarctica. It was great to see continental geology as a New Zealander, but I ended up on different things in my life. And the only thing I can connect back to Prof. Clark is that eventually I got into geochronology, thermochronology, and basically one of the founders of thermochronology of the methods I use today was Robert Strutt. And Strutt had been at Imperial College, and he was Arthur Holmes's supervisor for his PhD, and then Arthur Holmes was the supervisor for Bob Clark. And then I was here at the university, and many years later, I came back to do things that can link back to Strutt, Clark, and Holmes. So thanks very much.